All right, good morning, everyone. We're happy to see you on our webinar about the school security system. We are happy also to see a lot of people coming back again and again to our webinars. Today, Rob Versmissen, I'm the host of the webinar, and my colleague Kakit will give the explanation on how the solution works. So, Kakit, can you go to the next slide so everyone can see your face and my face on screen? Yeah. So these are the two people who will guide you through the presentation of today. We're also very happy to say that we have an external person who will explain more about a project he has done on the school environment and gathering mobility data for that. But before we start, I would like to introduce, for the people who are here for the first time, to explain who Macq is and what we do. So Macq is a family-owned company who exists almost for 100 years. Today we are with 130 engineers who are all working on software and hardware developers to deliver to our clients. We are a Belgian located company with an international sales throughout Europe and the rest of the world. We have a revenue of 20 million euros, and our business model is to sell self-developed products which are specially developed for our clients. Since 2001, we develop intelligent cameras, and we develop as well the hardware and the software. So we have a focus on smart mobility, and also from a history point of view, we also focus on automation. All right. So first things, we would like to give some facts about school environments and the usage of cards in that area. From study, we know that a mobile phone will increase your driving reaction time with 30 to 70%. So that also means that your braking distance will increase with that same percentage. And from all 78% of all traffic accidents involving children during school hours, they occur within a region or area of 300 meters around the school. So that means that the school area is a very critical point in the path of getting to school. And that 5% of those accidents happen in the school environment with a 20 or 30 kilometers zone limit. So Macq has been, like I said earlier, Macq has been developing solutions in the smart mobility since 2001. And we know that the school environment is a very important aspect in the smart mobility. And we have our applications that we already use for almost 20 years in smart mobility. But now today we would like to show how they can be used in a school environment. And of course, we didn't want to start unprepared in this area. So therefore, Macq was part of a European project. And therefore, I've invited Lee Verhaas. And Lee Verhaas is the project manager of the Polyvisu project. It's a project which actually ends today. So we can say we work until the end of the project with the full of our heart. And so, Lieve, if you're available, I would like to give the word to you.
Thank you, Rob. Good morning, everyone. So, yeah, first I will try to take over Macq's screen. Yeah, it looks fine. So, so the Polyvisu project was an European Horizon 2020 project that runs for 3 years. It was an honor to coordinate the project and to work together with 15 different partners, and Macq was one of them. And of course, together with Macq, we worked together on school environment, ANPR, camera-related projects, etc. And today, I'm very happy to present what we have done regarding school streets in Flanders, in the city of Mechelen, to be more precise. Yeah. One back. Yeah. So we started, in fact, from a policy question of the city of Mechelen. And Mechelen just want to measure the impact and the effect of implementing school streets around the school. And maybe a few words about the concept of a school street, because it's since 1.5 years, it's legally possible in Flanders to block a street during the morning and the evening when children are going to school or going back from school, to block the street for certain, let's say, road user categories like cars, lorries, etc. So that means that, let's say, the school environment itself can be reserved for cyclists, for pedestrians, etc., to go to the school. What's interesting is the fact that Mechelen wants to measure the effect before the implementation of the school and after the implementation. And to do that, we have used a device that was developed in Flanders, which is called telraam. And telraam in Dutch means, in fact, a counting window. But in English, it's also, when you translate telraam, not literally, then it also means abacus in English. So it's, let's say, it's a very nice name for that product. And in fact, telraam is, and here you can see a device, is in fact a Raspberry Pi computer with a camera you can put for your window. So it's a low-cost device that, as a citizen, you can buy yourself. You can install it for your window, and it counts cars, lorries, pedestrians, and cyclists. It's a low-cost solution, but it can be used to count traffic. And what you see here, for example, is Leuven, where there are already a lot of those cameras installed in the neighborhood. So the idea for school streets was, in fact, to measure the traffic, not only in the school streets itself, here in Mechelen, where you see the school street, but also in the surrounding streets. And so we asked citizens, it is kind of a citizen science project, we asked citizens to install a camera, and most of them were parents whose children go to school there. And together with the city of Mechelen, we were able to count cycles. And why we have chosen to count cycles, because from cyclists we can be sure that they start from where they live, come with the bicycle to school. And we install a kind of, let's say, policy goal, policy norm, where we said, okay, we will be successful when 110 cyclists come to school every morning or every evening, which is an increase of more or less 20%. We're also able to compare two periods, and we were a little bit lucky or unlucky, it's the way you see it. We were able to install one school street in Mechelen in the end of February, beginning of March. So we were able to measure the effect of the implementation of a school street beginning of March for a period of 10 days, because afterwards we were facing the first Corona lockdown. So here you can see some graphs below where we compare the period before the implementation of the school street, when we started already measuring, and the period after the implementation of the school street. And there you see the differences in number of cars in the neighborhood, the number of cyclists in the neighborhood, in the school street, etc. So we can do that in absolute numbers, and we can do that also in a relative way. What's of course also important, and as a policy objective, is of course a change in the model splits, and to have or to become a model split more in the direction of sustainable transport modes. What was also important as a policy objective also for the city of Mechelen was the aspect of public participation. So we are here, let's say, we have implemented here a dashboard that is mainly covering the soft side of, let's say, working together with citizens around traffic, around school streets. And what was also interesting, that we were able to also be in contact with the neighborhood, because what you what's a normal reaction of people in the neighborhood is in fact saying, okay, it's good that the school street is implemented, but what will be the effect, probably the negative effect on the surrounding streets? So as a first result, by the way, we noticed that there was almost no negative effect on the surrounding streets. So in fact, it was a very positive outcome of this first implementation of the school streets. And we hope after the, let's say, COVID measures are a little bit more normalized, that we can, of course, do more implementation in other schools as well. So we were also facing some, let's say, data challenges, and that was in fact getting local traffic count data. So we used the Telram there, but we will also look how we can make use of more, let's say, advanced counting cameras as well, like those provided by Macq. We were able to do a pre and post measurement, which was really, really interesting and necessary in my view. We were also getting insight into other data, like school holidays. We also implemented in our dashboard a weather engine so that we can see the impact of the weather as well. Another challenge we had to face was data shortage, in a way that sometimes cameras are not working, so we have sometimes some interruption in some streets. So we also have to deal with that as well. So our solution, to go a little bit more in detail on that, is, of course, we have implemented a policy dashboard, a dashboard that allows us to roll out numbers of schools. So we have also a dashboard where we can easily implement other schools and roll out other schools as well. Really important in our policy dashboard was to have this kind of policy goals for cyclists, for number of pedestrians, decreasing cars, etc. So very important is also the aspect that this is reusable, not only in Flanders, but also on the European and worldwide level. The concept of school streets, by the way, is also implemented already in the north of Italy and also in Scotland. There are some initiatives going on, but even without, let's say, the legal measures around the school street, this can be still very interesting. We mean also that the dashboard is very easy to interpret and to use. It's also, let's say, an educational tool for schools and as well. And it provides also very interesting information that will be shared between the local community, the schools, but also the citizens. And I think that's a real advantage of what we have done. We see that we want to connect multiple sensor devices in the future, as I said, like the Macq, more advanced measuring devices. Policy goals, reusability is a really important thing, and so on. So here at the school, we have implemented 10 so-called Telram sensors. We can choose, in fact, how much we want to integrate there. So that's just up to us. We had a policy norm of 110, I have to say, cyclists. And so we have this first rolled out in one of the primary schools in Mechelen. But we can, of course, provide multiple, we can do that for multiple schools as well. Then some takeaways to end my presentation. What was really important was the aspect of public involvement, citizen science, in fact, as an enabler to collect data and to use data on a local level. Data itself is not enough, so also we need that public involvement. We need also people who can study the data, who can write a report with the results, etc. It's all about what you do with the data. So in that respect, it's important to provide that kind of policy goals. And in fact, it's something we are missing in a lot of smart city dashboards today. Easy to interpret visualization, but also uptake by local politicians was really important because citizens can, of course, install a counting device, but it becomes interesting for them if they see that the results are taken up by the local politicians and that our measures are taken. In our dashboard, we also want to implement some gamification, so to encourage further participation, to compare schools with each other, to compare different measures, a combination of measures installed and applied as well. And we want, or there is also the possibility to make this approach also applicable in other domains, like measuring the impact of local mobility plans, or to measure traffic around hospitals or shopping areas. So the possibilities to integrate this, let's say, soft approach are much wider than school areas alone. So last but not least, I really like to invite you to go on our website, Polyvisuals EU, where you can find more about, let's say, all the cases we have done in Polyvisio, but especially this one around school streets. Thank you.
Thank you, Lieve. So I think one of the important aspects that we have learned from this project was the fact, the community aspect, that you not only need to gather the data, but that you need to involve the environment to make it a successful story. And that's also something that Kakit will explain, that we want to involve the people, and that we want to show directly the positive effects of their behavior on the safety in a school environment. But before I give the word to Kakit, I also want to remind everyone that whenever you have a question, you can pose them via the Q&A or chat, and we will try to treat them at the end of the presentation. So I think the Polyvisio project has learned us a lot on the community aspect, the soft side, the fact that you need to involve people, that it needs to be in a positive atmosphere for a school environment. And we also think there is we have not only learned from the project, but there is also a nice synergy. What our solution can offer is a very precise and accurate information in the direct surroundings of a school. And with the Telegram and the dashboards that they've made within Polyvisio, you can have a broader view on the side effects in a broader area around the school. So I'm now very glad to give the word to Kakit.
Thank you, Rob. With Macq's school security system solution, what we're aiming to do is to make people aware of available technologies today, with the goal to make areas around schools safer in a sustainable but also an adaptive way, while considering the specificity of each area. And how we do that is through the following concepts. The first one is to monitor the average speed on vehicles approaching schools, to create awareness and to potentially also penalize speeding drivers to change their behavior. A virtual message sign will warn and inform people on the school area. The VMS can display a program message or can actually be driven by other sensors such as smart cameras with AI capabilities. We can also create a restrictive traffic zone with a white list for vehicles that are allowed to enter and a blacklist for those that are not allowed to enter during school hours. Also, a very important measure could be to monitor school kiss and ride zones, also using AI algorithms that can determine overstaying events. And last but not least, standalone sensors are not really valuable unless they're centralized in a platform that aggregates all the information and displays it easy to, in a way that it's easy to understand. So meaningful statistics. Examples can be vehicle counting, as Lieven has showed, or like a traffic volume graph, and so on and so on.
Yeah, so we also have an interactive poll. We have one here and we have one at the end of the presentation. So the first question we want to ask to you is, how much do you believe that the local school environment needs protection? So you maybe can compare it with the situation of the schools that you have in your area or the schools that you bring your children to. And we want to know whether there is actually a need for the product that we're building. So I think the poll should be popping up on your screen right now, and you have the possibility to choose one of the options. And the options is that you strongly believe that this is a required system, that this is necessary. You somewhat believe it could be added value, but it's not so important. You somewhat disbelieve in such a solution, or the fact that it needs more protection, or they say this is absolutely not necessary, so then you can click on strongly disbelieve. So I think you have now the option on your screen, and that you can make the choose. You can choose which option you would like to take. All right. I think, Kaki, do you have a
Yep.
view on the results?
Yeah. So we have 59% of people strongly believing the environment needs protecting, like school protection, and then 35% that somewhat believe.
Okay. Well, that's at least very good news to hear. So maybe we can actually present how we can do this, and then we can see further whether it's a match with the needs of the market.
Yeah.
All right.
So I'm also glad to hear that most of you share our point of view. So our previous mentioned concepts for an ideal integrated school security system is visualized in this illustration. So I will go through them through all these pillars one by one, and actually explain why each pillar will contribute to a safer school zone. So we have firstly monitoring and definitely also enforcement of average speed, which will improve driving behavior over time by reducing speed of passing vehicles at school areas. And that will actually logically lead to a decrease of number of critical accidents. So the main goal here is to improve compliancy within speed limits over a distance that is most likely to be defined as an accident-prone area. We have a restricted traffic zone that can be created, which comprises of all the streets surrounding the school. And with this application, the whitelist concept is implemented. So only authorized vehicles such as local inhabitants, registered vehicles from pupils' parents, emergency vehicles are allowed to enter during the school days. Also, the restricted zone schedule can be pre-configured, for instance, for 30 minutes prior to school starting and 30 minutes after school ends. Also, variable message signs are proven to be quite effective, a quite effective way to draw attention of road users when there is a presence of children. Automated signs such as speed limits can be displayed on a VMS. Also, the VMS can additionally be driven, as I said earlier, by a smart camera to project positive or negative driving behavior. So as you can see on the picture, it is quite feasible to display in real time certain behaviors of road users that could be captured in real time to try to change their driving behavior. How should the driver behave on a kiss and ride zone? So a kiss and ride zone often has limited amount of parking spots, and parents usually stay for like a small chit chat with other parents. So to prevent overstaying, what we can do is place a sensor on that zone that measures the time of period a vehicle has stopped on the same spot. People will be aware that they're actually within a monitoring zone, so they will actually change their behavior immediately afterwards. So this is a video that shows the capability of artificial intelligence algorithms to detect road obstacles. So as you can see, there was an obstacle on the street which might be a dangerous event. And all this has been detected with our camera, fully processed within the camera itself. And you might think that this video is actually out of today's topic, but the reason why I shared this video is to show you how one sensor with deep learning capabilities can be used for various applications, such as detection of dangerous scenarios. On today's Safe School topic, for example, object detection, validated obviously afterwards by human eyes, can be used for notifying local police forces in case of suspicious objects near a school. I will also show another example in just a minute. So with pedestrian warning systems, the driver can be alerted in real time if a sensor has detected a person within a certain region of interest. In this case, that would be close to or on the pedestrian crossing. With this kind of warning signs, driver will also adapt their driving behavior. And the next video will show the feasibility of person detection on a smart camera that can be then used to push real-time messages on pedestrian warning signs. So, meaningful statistics is also of essence to better understand real-world problems. It does not only raise awareness with easy-to-comprehend charts, but it can also help in a more effective way policy decision-making for further improvements. Important KPIs in a safe school zone could, for instance, be the number of detections above speed limit over time, prior and after implementing a school security system. The same goes for counting of vehicles throughout the school zone area, or a traffic intensity map, which can be seen here, showing the time period and days on which traffic flow is high or low.
Okay, so I also just want to mention that the dashboard that you've seen with the statistics is the dashboard on the speeding behavior that was also constructed within the European project of the Polyvisu and has been constructed together with the input of different police zones. So I think what is important in the school security system is that we have different tools to secure the environment. As like Kaki said, we have the average speed control to reduce the speed. We have the possibility to restrict traffic, could be based on license plate or on vehicle type. We have the possibility to make use of variable message signs where we could show the traditional speeding limit and the behavior. They're driving too fast or they're driving okay. But of course, we have a lot of other ideas that we would like to show on those signs. We could show, for example, the amount of cyclists that came to school that we gather for our own cameras or from the Telegram cameras. We could show that people are using the zebra crossing correctly or not. So there are a lot of things that we have as options to do. We have a lot of experience and we have the applications to use. But in our next poll, we would like to know which, to your opinion, are the most important ones to apply in the school environment. And we have 6 possibilities, and we have given you a choice of 2. So from the poll will be shown on your screen in a few seconds. And we would like to know which of these 6 applications to use in the most important one in a school environment. So you can select up to 2 from this list. So we have the average speed, we have the restricted traffic zone, which can be on license plate or which can be on vehicle type. So it can be saying, it can also act in the way to restrict, for instance, trucks during opening and closing times of school. The variable message signs, where we, on the one hand, want to show people who are not following the rule, but mostly we want to focus on the positive aspect, the positive behavior, and focus on the community aspect of it. So saying so many cyclists, so many pedestrians. The kiss and ride zone. So we know that definitely in cities, schools have no endless limits in area, so they have only a small part of parking spots. So in kiss and ride zone can make that more efficient and also more safe. We have the pedestrian warning system to see when children are on a zebra crossing or when there is any dangerous situation with a pedestrian. And then you have the meaningful statistics, of which can be used by the school itself to see the behavior of people coming to their school, or the local community, or any other authority that can do anything with these statistics. So we are very looking forward to the results. Before I will go to the results, I also want to say that you still have the option to post some questions. I didn't get too much right now, so maybe it's because you're blown away of all the information you've got, but if you like, you can type your questions and then we will answer them. So we can now see the results of the poll. We see that the top functionalities, according to your opinion, are the average speed and the restricted traffic zone. They both have like 46% of the votes. And then the second one is a variable message sign, where we can say the positive message of the good behavior, but also if someone is driving too fast, you can mention, hey, take into account the speed limit. And then the pedestrian warning system. And then as a fifth and a fourth, we see the kiss and ride zone and the meaningful statistics. Okay, so I will now have a look at the questions that we have got throughout this webinar. And the first one that I got is on the Telegram solution. It's a question of Jos de Bozere, and his question is, what is the quality of the low-cost Telegram RPI solution? So I can give my insight, maybe Lieve, you can complete my answer. But the Telegram solution is, as Lieve explained, focusing on the counting of pedestrians, cyclists, cars, and lorries. So it can distinguish these 4 categories, and it's focused on the counting of that. So it's not as our solution focusing on the ANPR, which allows a lot of functionalities like the average speed, the restricted traffic zone, etc. So the focus of the Telegram is more on the counting in the surrounding area or whatever goes to a street. So I don't know, Lieve, whether you can say something more about the quality of it.
Well, so first of all, yeah, the algorithm there is an AI algorithm running on a Raspberry Pi, which is of course a computer with limited capacity to do this kind of things. So as far as I know, because I'm not the specialist there, the camera has a kind of learning mechanism, and especially this one is important to make the distinction between cars and what we in fact call in Telegram heavy vehicles, because it's not only lorries but also buses and probably vans are counted as big, let's say big cars. A second aspect important for counting is of course the positioning of the camera. The positioning of the camera of course depends. Yeah, it's been asked to install the camera on the first floor. And then of course much depends on the street itself, especially for example counting pedestrians. It's sometimes the case that the camera can not perfectly count people who were walking very close to the house, let's say. So the range of the camera is, in some cases, is not optimal. A second point is, especially when it's dark, the Telegram camera is not able at this moment to count or to do perfect countings when it's dark outside. So it counts, in fact, for example, related to the school streets, optimal in the periods, let's say end of February, somewhere in October, but during the winter months, it's more difficult to have exact countings.
Yeah. Okay.
So there are, of course, a number of drawbacks that you have to take into account. But on the other hand, I think the device is and was interesting because, of course, it also counts relative volumes to each other. So that's also for, let's say, for school street purposes, is also something interesting to take into account, to just see the evolution.
Yeah, and I think we can state that if you look at the scope of what the Telegram wants to achieve, it's a fantastic product. If you look cost and performance-wise, it's really doing a good job. It allows you to see the tendencies, so in a larger area. So even if it wouldn't be that low cost, we would not be able to install it in so many places. And it's very important to use it to measure tendencies. And so it will give you an indication in the evolution of the surroundings. But of course, it's not the objective of the system to solve all security issues around schools. It's just extra eyes on and view on the world around the school. Yeah. Then I will go to some other questions. So another question from Michael Petit is, can you please further explain the type of real-time capture behavior of users captured by the cameras that could be displayed on the virtual message signs in real time? So I think that's a good question. The thing is that what we have cameras in the fields who can detect behavior. So the applications that Macq explained. And of course, we have a back office software where you can see how many people were speeding, people who were not allowed in the environment, etc. But one of the things that we have learned from the Polyvisu project is to involve people, and you need to create a sort of community around the school. And of course, you can do that with statistics that you share with the parents of the kids, etc. But it's also important that you can give a direct feedback on the behavior. So we know that people are mostly influenced if they get a direct feedback after they have done an action. So at that point, we're exploring on what we can show. So we want to have that the variable message signs cannot only show the typical thing like you've taken into account the speeding limit of zone 30, yes or no, and you notice the happy face, the unhappy face. But in fact, we want to show much more, and we want to show actually information that we have from the different options that we have over here. So the speeding behavior, that's definitely something, but also the counting information we would like to show. Also on the pedestrian warning system, that's definitely information that we can show directly. But it's, I think, a challenge to find continuously interesting information over there that can be shown over there. Because I also have another question of Lien Willemkes, and she's saying, well, the signs, they're okay, but after a while, everyone knows the sign and maybe they don't react on it anymore. I think that's a good point. I think everyone knows the first time they see a sign, but if they pass there 100 times, their reaction will be different. So one of the challenges is to make sure that you can show statistics or new information over there that is relevant. So with the current way of the VMS signs, you have always a speed limit. I think it's important that you can vary over there, that you can show different informations throughout different weeks, so you can keep everyone involved. That is definitely a challenge. I see that more and more questions are popping in, so I will go to the next one. The next one, is the average speed system capable of giving fines? Is this an enforcement system? So the answer is yes. It has the possibility to give fines. So we have a homologated system that can give fines from a speed limit from 30 km/h to 250 km/h. So it can be used for this as well. It's not mandatory. It can also be used as an information, as an input for the variable message size. But it's of course up to the policy of the local community or the school what they would like to achieve, and if they would like to use it as an enforcement system, that's definitely possible. So the next question is the presented solution available? How long does it take to install it? So all the building blocks we have over here, we have done that at other locations as well. So it's definitely possible to install it. We just have to make an agreement when we can start. And then I have the last question for now, and that's from Luc Smeijers. And he says, from experience, school location and urban design have a big impact. It will enable or limit the possibilities, for example, for speed control. Therefore, it's interesting that you offer a toolbox with various technical solutions that match actual situation. So indeed, that's what we want to achieve. We don't want to give one solid block. We would like to give some options that can be implemented depending the situation around the school. We know that you have school environments in cities, you have school environments on, let's say, in the country, where you have more or where you have less space. Also, how the road layout will allow or disallow some of the functionalities or indicate which are more or less important. So I think it's important that we are flexible and that we can respond to the direct needs of the school. So I think we have now gone through all questions. We would like to thank you for being here once more. We are very happy to see that people come back again and again. So we have a public which is very loyal, but we're also very happy to see new people attending over here. And what I also wanted to say is that you will get a link from where you can review the webinar once again. So it's a recorded webinar. So you will have the possibility to see it again. And of course, if you have any questions, you can always contact us. So you can contact us via the email address from which you get the link. And I think, Kakit, in the next slides, we also have our contact information. And if it's not on next slide, it was definitely on one of the two first slides. So many thanks to be here, and we hope to see you next month. All right, bye.